Okay, well, I went ahead and pulled the cylinder back off here, and you can see here we got it down. Now, what I was talking about here, I'm going to tickle the lower transfer ports here. What I mean is these your lower transfers here, where they feed in from the crankcase here. They have kind of a square face on the divider here between the quad ports. Now, what I'm going to do is probably well, I'm going to work them down into a point, the edges here. Now somebody will probably argue with me and say I shouldn't do that, but the idea is instead of having a square stop or block here to, I want the flow to go in nice and strong. I've done that before on a couple other saws and it seemed to have worked well. So I'm going to go ahead and try it on, never done it on a 357, so we're going to see here, like I say. Unfortunately, I don't have enough light here to see, but like I say, there's some little scratch marks here right in the front of the cylinder here. Unfortunately, they're not deep. I can just barely feel them, and most people would say it's not even an issue. I know a lot of saw builders would just go ahead and use a cylinder like that and not even think twice about it, and I'm not either. For the most part, the rest of the cylinder is in really nice shape. It's not a not a major concern. Like I say, I don't have the tooling to get in here and do the upper transfers to open them like some guys do. They'll extend them or put a little bit of angle on them to wrap the charge around into the back into the intake side of the combustion chamber and get a little bit better boost out of power that way. But I will, like I say, taper these down to a point here. And something interesting I'd like to show you folks here. On these here, like a lot of saws will have a raised cylinder skirt here where it comes down into the transfer case and slows the transfer port flow down. These actually are where the inner cylinder liner wall here ends is actually lower, a little bit lower than, it's cut lower from the factory than the outer base. So it goes to show they were pushing the performance envelope at Husqvarna when they were designing these to get them to really, you can see here on the other side here, it kind of shows up there on the camera. The cylinder walls are actually cut down lower than like I say, the outer base or the mounting base. So they were already trying to push as much charge as they could, up into the combustion chamber from the crankcase. And these saws, the 357 XPs, have the circle crank stuffers in them to reduce case volume to get them to spool up or rev up faster. The 359s don't have that. They have the open crank without the stuffers in them. So these saws had little go fast tricks already incorporated or designed into them. But I want to get a little bit more intake charge into it a little bit quicker. Instead of grinding on the intake side and moving ports around, or I'm just going to leave it in its stock or standard form. And to achieve that, I'm going to take and grind a little bit here, bevel the bottom edge of the piston skirt on the intake side. You can see here, I don't know if it'll show up on camera, I used the lead pencil on the inside of the intake port to mark where the piston closes off from where the front of your exhaust port, where your compression ring clears the top of the port. Now that's important because you don't want to have before your ring, you can't grind so much off the base over here, like cut it all the way up or take a whole bunch of material or too much material off before your piston ring is up past the exhaust port on the opposite side here on the front. Because what will happen is you won't build proper compression and then you'll be what they call like free porting. I marked it here just where the ring clears the front of the exhaust port, where it's just above it, where it's closed off. And this is what's left here of the skirt in the closed position here behind on the intake side. That's your compression stroke. So you have to make sure that you don't exceed that line here. That's where it's marked, where this piston ring clears your exhaust port. When it's closed off, this is how much skirt you have left. I'm going to remove about 1/3 of the remaining closed port portion. so that when the piston comes up, it will open that much sooner to get, like I say, that little bit of extra charge in there. Will it make a big difference? Possibly. I've heard that it does, so I've never tried it, so I'm willing to give it a try. Like I say, this piston is not bad shape, but it's got just a tiny little bit of wear at the bottom edge here anyways, so we're going to go ahead and basically take and remove this, not all of it, like I say, about a third of the cutoff point here. Like I say, you've got your you don't want to go past that line. Compression stroke is closed off, like I say, once your compression ring comes up past the exhaust port. So, but anyways, this is the intake side, and interesting, I marked the exhaust side when it's in that position. I'm going to go ahead and remove the piston, and I'll do that off camera. Don't need to bore you folks showing you that, but I'm going to go ahead and do a little bit of grinding on here with just a simple die grinder, and I should have it chucked in a lathe, I guess, so it's all nice and evenly machined properly and all that. But now some guys will just take and grind on the back side and not bother and leave the front side. But I'm going to actually do both sides of the piston because I want it to be balanced, because these are a high revving saw. I'm going to try and keep it balanced and the best I can. I will keep a tab on with a caliper to make sure that I'm you know, staying square and straight and all that. Like I say, not an exact science. I'm just a logger farmer, you know, chainsaw fixing hack working on his bench in his shop, experimenting and playing. So this is going to be a play saw for me at the moment, and if it turns out to be a great work saw, well, so much the better. But anyways, that's the theory of what I want to do and what I'm going to try, and I think we're going to call this a video here. I've already rambled on long enough, but just giving you insight as to where this project is going to go and what I'm going to do with it, and we'll start building it up from here. We'll do the piston, and then I will clean everything up and start the reassembly process and get everything back together and slowly go through it and put the saw back together and get it running, and well, we'll see what I end up with. If I end up with a really strong running saw or just a so-so turd saw. So anyways, I'd like to say thanks everybody for stopping by and checking out another one of my videos, and don't forget to like, share, subscribe. It's greatly appreciated, and don't forget to leave a comment in the comments section. I always like interacting with you folks, and well, I enjoy my time talking with you guys. So anyways, thanks everybody once again, and we'll see you all in the next one.